basic electrical and electronics engineering, electrical circuits. Before we delve into the study of electric circuit, we should have some fundamental components, fundamental aspects of electrical circuit. So these things you might have studied in your school level. It's only a recall of the very fundamental concepts one should know before start studying the basic electrical and electronics engineering. Basic concepts of electricity, atomic theory basics. So this is atomic structure. Atom has got a nucleus which is at the center, and surrounding the nucleus we have the circulating electrons in various orbits. So the nucleus is made up of two type of particle: proton, which is positively charged, neutron without any charge, neutral or without any charge, and the electrons have negative charges, negatively charged. So the electron revolve around the nucleus in various orbits. You can see, so it revolve around in various orbits. The last orbit or the final orbit is called valence orbit, and the electron revolving in that orbit is called valence electron. So the influence of this nucleus on the electron vary from the position of electron from the nucleus. That means the electron, this electron, I will use a pen. So this electron, right? This electron has got more influence by the nucleus than this electron. So that means this electron is tightly bound to the nucleus, whereas this electron is very loosely bound to the nucleus. Next, conductors, insulators and electron flow. Insulators. An insulator is a material that does not conduct electrical current under normal conditions. Most good insulators are compounds rather than singular materials. Valence electrons are tightly bound to the atoms in case of insulator. Therefore, there are very few electrons in an insulator. Next, we have conductors and electron flow. So conductors. A conductor is a material that easily conducts electrical current. The best conductors are single element materials such as copper, silver, gold and aluminum, which are characterized by atoms with only one valence electron very loosely bound to the atom. So that means, so this is the last orbit or extreme orbit. So this electron, the electron in this orbit, they are very loosely bound to the nucleus. So what happens, these loosely bound valence electrons can easily break away from their atoms. So it can break away from this, it can break away from their parent atoms and become free electrons. Therefore, a conductive material has many free electrons. See, this is a piece of conductor. You can find a very large number of free electrons. Suppose if these electrons move from one point to another or in a specific direction, then it is called current. Therefore, a conductive material has many free electrons that when moving in the same direction, I don't know. Suppose moving in the same direction, say for example, moving in the same direction, make up the current. Electric circuits, in that what is current? We have already said what is current. The actual substance that is flowing through the wires of the circuit. So the electrons, flow of electrons through wires or through the conductor is nothing but electrons, but that flow should be in one specific direction, say from left to right, top to bottom, bottom to top, or right to left, like that. Okay. So it is similar to the movement of water droplets through a river stream. So what is electric circuit? A continuous path in which electrons flow. And what is load? A device that converts electrical energy into other forms of energy. For example, lamp or motor. So here we have a battery, the positive terminal and negative terminal. So it is a source. So this is a source. And motor, here the energy is consumed, electrical energy is consumed, or in other words, it is converted into other forms of energy. So in a motor, electrical energy gets converted into mechanical energy. So here we have a switch that controls the flow of current. Okay. So electric circuit, a continuous path in which electrons flow. Switch, a device that controls the flow of electrons or the flow of current by opening or closing the circuit. So now this is open switch, right? This is open switch, and now the switch is closed. Okay, here you can see we have a battery with a positive terminal, negative terminal, and we have a load which is nothing but a motor, and this is positive terminal of the motor, negative terminal of the motor. Through wires we have connected with the battery. So through a wire, so this green color is wire. Okay, now this current is nothing but flow of electrons. So you can see electron will start from the negative terminal of the battery. It will go through this motor. It will come out of the positive terminal. Finally, it will reach the positive terminal of the battery. Okay. So this motor, in this motor, the electrical energy gets converted into mechanical energy. So when current flows through the motor starts rotating. So there are two types of circuit. One is open circuit, other is called closed circuit. So what is open circuit? An incomplete path that will not permit an electric current to flow. Here you can see we have a battery. So this is battery, positive terminal, negative terminal, we have a bulb, we have a switch. So now the switch is open, so there is no current. Current is not there. So it is the case of open circuit. Another example, here we have a battery, we have a fuse to protect the circuit, you have a switch but it is open, you have the load which is the bulb. Since the switch is open, current is not there, current is zero. Okay, so it is an example of open circuit. Closed circuit is nothing but you have a complete path for electric current. Here is the demonstration of closed circuit. Say for example, here we have a battery. So this is a battery. Say this may be positive terminal, this may be negative terminal, right? And we have a fuse protection device. These are all the wires. Okay, this red color is wire. So this is the load, which is a lamp or bulb, and this is a switch control device. Okay, suppose current is nothing but flow of electrons. It will start at the negative terminal of the battery through the closed switch and through this bulb, and it will reach the positive terminal. So when current flows through the bulb brightens or glows. So it is an example for closed circuit. So here also closed circuit examples. We have battery connected to a bulb. So current flows through the bulb glows. Next we have conventional versus electron flow. See, just now we have seen the current is nothing but flow of electrons in one specific direction, right? But before the discovery of this concept, people were thinking that current is nothing but some invisible fluid that moved from higher potential to the lower potential. Just like a fluid that moves from high pressure to low pressure area, low pressure region. So they assumed that current always starts at the positive terminal and it will reach the negative terminal. So with that assumption, they created all the laws, rules, theorems, etc. And since it has already established whether it is moving from positive to negative or negative to positive, it is the flow in one specific direction. So the answers may not change, right? So we just adapt to the conventional flow. That means we assume that current always starts at the positive terminal. It will flow through the various parts of the circuit. Finally, it will reach the negative terminal of the battery. Okay, this is what we are going to use. This is called conventional flow notation. Sometimes in some people they follow the electron flow notation. That means that is the actual current flow, right? Electrons leave the negative terminal of the battery and finally it will reach the positive terminal of the battery. That is called electron flow notation. So but we are going to follow, and most of the people will follow, this conventional flow notation. So there are two types of current. One is called a direct current, another one is called alternating current. So a flow of electrons in one direction through an electric circuit. It is a form produced by batteries. For example, if you assume conventional current always from positive, it will reach a negative. Always it moves only in this direction, so it is a direct current. Another is called AC or alternating current. So the flow of electrons or the flow of current that alternates in direction in an electric circuit. So this type of electricity is produced in generating stations. Say for example, the EB supply, the current is alternating current. First it will flow, sometime it will flow in this direction. After some time it will changes the direction. So again it will flow in this direction, again it will change direction. So this is called alternating current or AC. For our household supply, we are getting the AC or alternating current. So your fan and your grinder or your mixie, all are operated using the alternating current or AC. Next we will see two important concepts in electric circuit, that is called voltage and the resistance. So voltage, a force that pushes the current through the circuit. So it is also called EMF or electromotive force. Some force that pushes the electric current through the circuit. So it is like a flow of water from a higher potential or at a higher pressure region to the lower pressure region. Say for example, we have a pond, we have a reservoir, pump sucks the water and it fills the reservoir. So the energy gets stored in this case. So this is similar to a battery, right? The positive potential of the battery equal to the reservoir, negative potential equal to the bottom pond. But here there is no flow, just at a higher potential energy is stored. Suppose you release the water from the reservoir through a pipe, the energy gets released, right? Suppose you combine these two things. So we have the pump that is taking the water to the reservoir. From the reservoir, it again flows back to the pond. So there will be continuous circulation of water through the system. So this is what happens in a electric circuit also. For example, here current will start from positive. I am using conventional current, negative terminal. So this will be keep on, the current will be circulating through the circuit like this, just like water is keep on circulating through this system. Okay, so this is an example for voltage. So the battery produces the voltage and the unit for voltage is called volts. The symbol for voltage is capital V. Next we have resistance. It is denoted by the letter capital R. The unit for this resistance is ohms. So what is resistance? The friction that impedes the flow of current through the circuit. So it is similar to, we have a river. Suppose if the river bed is very smooth, water will flow without any obstruction or without any what do you call blocking. So suppose if the river is full of rocks, so there will be a friction to the flow of water and the flow of water gets impeded. Similarly, in the electric circuit or in the various parts of the electric circuit, there is a friction that impedes or that slows down the flow of current through the circuit. So this quantity is called resistance. Now these three quantities, that is voltage, current and resistance, These three are related by each other and related to each other, and it is given as Ohm's law. Ohm's law states that I, current I equal to V by R. Current I equal to voltage divided by resistance. So there are three forms of Ohm's law. One is, say for example, E means voltage. This both are same. So this you can put V, capital V. Suppose I want I, you put V here, I and R here, you put one divider. Suppose I want I, you just close this. So I equal to E by R. Suppose I want V. Okay. So V equal to I into R. Suppose I want R, you close this. So R equal to E by I. So these are the three forms of Ohm's law. Thank you very much.